Anyone study calculus will be very familiar with L'Hopital rules. L'Hopital rule is one of the very powerful tools when we want to find the limit. However, for today's lesson, we are going to provide a scenario that L'Hopital rule doesn't help a lot. First scenario, the limit of square root of 1 plus x squared over x when x go to infinity. Now we see that in this case, we can use L'Hopital rule because the numerator will go to infinity and the denominator go to infinity. However, when you use L'Hopital rule, it means that we have to differentiate the numerator. It will give us 1 over 2 square root 1 plus x squared times 2x. After we differentiate the denominator, we get 1. And 2 can be cancelled off. And now I will have x over square root of 1 plus x squared. Again, it is infinity over infinity. If you apply L'Hopital rules again, then we'll get back this expression again. And we are unable to get the final answer from here. So this is the first scenario that L'Hopital rule seems not so powerful. The second scenario, it is limit of e to the power of negative 1 over x when x go to 0 plus. Now what happened here is that when x go to 0 plus, negative 1 over x will go to negative infinity. E to the power of negative infinity will go to 0. The numerator go to 0 and the denominator go to 0. Now we can use L'Hopital rules here. So we differentiate the denominator, we get 1. And for the numerator, we'll have e, negative 1 over x, multiplied with, differentiate negative 1 over x, it is equal to 1 over x squared. So what we have here is e to the power of negative 1 over x over x squared. And again, it is of the form 0 over 0. If we're going to differentiate one more time, then we'll see that this will equal to e negative 1 over x, 1 over x squared, and this is 2x. And we will have e to the power of negative 1 over x over 2x power 3. So in this case, L'Hopital rule does not simplify our expression. Whenever we apply L'Hopital rules, then the power of x will increase from x power 1 to x power 2 to x power 3, and we will continue. And it still cannot give us a clear answer. So how to solve this question? Get the answer directly without using L'Hopital rule. This limit, it just equals to square root of 1 over x squared plus 1. We can take this x inside the square root and it becomes square root 1 over x squared. And we have this. When x go to infinity, then this is equals to 1. That's all. If you still want to use L'Hopital rule, it is still possible that we suppose that the limit exists and let it to be L. If L equals to this, then whatever we have here, if the limit exists, this will be equal to 1 over L. Then L equals to 1 over L, and therefore L squared is equals to 1. L squared equals 1, from what we have here, this term is always positive, and therefore we have L is equals to 1 because it is always positive. It is also possible to get the answer using L'Hopital rule with the assumption that the limit exists. This solves the scenario 1. How about scenario 2? For scenario 2, we are unable to simplify it using L'Hopital rule directly, but we can use a suitable substitution. Erase this. And the suitable substitution will be let u to be 1 over x. If u equals 1 over x, when x go to 0 positive, u will go to positive infinity. So the limit e to the power of negative 1 over x it will be equal to the limit of u go to infinity. And this is e to the power of negative u. And and x will be equal to 1 over u. And this will change the position. 1 over u is actually equal to u. E to the power of negative u is actually 1 over u. Both of them go to infinity in this case. You can apply the L'Hopital rule if you want. Then we will have, this is 1. After differentiate u, that is 1. After differentiate eu, it is eu. And this is 1 over infinity, that is equal to 0. These are the two scenarios that L'Hopital rules may not seem so great. That's all for today's lesson. I'll see you again. Bye-bye.